Okay guys, let's continue with some more problems on factorization. In the last video, what we saw was one of the variations, the variation 1 on the defactorization that we saw. And I think normally only one type of problem comes in that kind of format, which we solved. In today's video, let's take another example. Like I explained in the previous video, there are two more variations, variation 2 and variation 3, which both deal with factorization. So let's talk about variation 2 in length. Let me solve it real time. It's of a problem you're going to solve with me, and then I'll solve it live and you can understand as one of the examples, and then you can see how to apply that in the other examples. So going on. So what is variation 2? Variation 2 is a problem where it is related to factorization and defactorization. But if you see the right hand side of the equation, right, on this side, you'll always have just one trigonometric function. You'll not have multiple trigonometric functions. For example, if you see the one that I've highlighted in blue on the right hand side, it's just one trig function. That's it. It's not an equation with other trig functions. Whereas if you see this one that I'm highlighting with violet color over here, this has got multiple trig functions. So that's a difference. So anything that is in sky blue color, this one and this one and this one, have just one trig function, and we'll just talk about that as a variation 2 in this video, and in the next video we'll talk about this one, which is in violet color, where you have multiple trig functions, which is variation 3. So let's move on. So let me take this problem, and if you see this winter 2019 problem, question number 3C, that problem is repeated twice. That exactly the way it is. It came in winter 2019 once, and it came in winter 2018. Looks like the exam guys love this problem and just give it. So you might as well want to practice this a couple of times, and then I think you should be okay. Whereas if you see this last problem, I'm not going to solve it real time. I'll just pre-solve it and explain you in another video. But this is a very simple application of one of these formulas over here. I've written the formulas here for reference, but it's a straitjacket explanation of how to apply that. So once I solve this problem, the top one, this is a very easy problem, and you can see how it is. Okay, so let's just focus on this video, which is going to just solve this problem, which came twice, once over here and once over here. So let's see what's going on. Okay, so let me write that problem first, okay, for the benefit, and then we can solve. So what they're asking is prove that left hand side is equal to right hand side, and like I always tell, right, whenever you have a left hand side is equal to right hand side, the answer is already given. You just have to prove that. So let's write this problem first and then start solving it. Okay, so the left hand side is sine of 4a plus 5a plus 6a. Let me write it down here. Okay, let's see. Okay, the left hand side is equal to sine of 4a plus sine of 5a plus sine of 6a, the whole divided by, and if you see, it has got all the cos functions with the same angles. And like I told you in the video when I was trying to explain you the concept, in the case of factorization, factorization, you'll always find this pattern where you have these terms which are odd, even, mixed, 4, 5, 6, and it will be always when you add two angles, somehow it will be even, so that you can apply this formula c plus d by 2, and it doesn't give you an odd multiple. So in this case, if you see 5a, if you take 5a and if you add 5a and 2a, for example, if you try to add this, if you try to, let me just take a different color. If you just try to add this and this, so it will give you, I'm writing here on the side, it will give you 5a plus 4a is 5a plus 4a is 9a, and then the formula, if you apply this formula, it will become 9a by 2, which is 4.5a. So normally whenever this things happens, you don't have to, you just need to understand that that's not the right two angles that you're going to take, so you have to take something different. So this situation should never occur. Other than that, if you add the remaining two angles, if you take 4a and 6a, and if you add that, it becomes 10a, and the difference will be 6a minus 4a, 2a. So it's an odd multiple, and it will be divided by 2. So that's kind of the hint there. Anyway, let's move on. So this is the left hand side here, and I'm going to take a different color for right hand side. So if you take the right hand side is tan 5a. So if you take the right hand side here, I'm going to right hand side is equal to tan 5a. So whenever you get a right hand side equation, always for the sake of reference, try to break this down or substitute in the simplest way that you know. You don't have to over substitute because we're not still solving the problem. We're going to start from the left hand side, but it will help you if you break this down, because as the left hand side unfolds, and if you see whether the left hand side is closely matching to the right hand side, it will be easier for you to see that you are approaching closer to the solution. So in this case, the right hand side, at the most what you can do is you can just write it as sine of phi a upon cos phi of phi. You cannot break it down more than that. That's hint number one. Okay, just break it down and write it down. And the hint number two is, if you see here, you have got 5a right here, okay, and you have got phi at the bottom also, and the right hand side also you need 5a. okay, so that means the left hand side has 5a, and like I told you right in the previous video also, normally the clue is the angle which is on the right hand side, the left hand side will have that equation or the angle somewhere hidden there. So it's not hidden, but it will be clearly visible. So if you see the right hand side has an angle of 5a, and you can clearly see not only that on the left hand side there is a 5a angle, but it's exactly kind of in the same proportion or same kind of a format where you have a sine upon cos and both the angles are 5a, and if you say here you have sine upon cos and both the angles are 5a. So you can see that. So that's a clue. So in that case, what you should do is you should avoid as much as possible to touch that piece of the equation as much as possible, and you should keep it for the last. Anything that you want to do it, you should not take it up front, you should keep it for the last. And that's not a rule for only for this kind of problems, it's kind of a thumb rule. Like if you see a pattern on the left hand side that matches the right hand side, try not to substitute that in the very first iteration, keep it for the later. Okay, that's a clue. So if you see here, left hand side has 5a, you notice that, just keep it for now. Okay, keep it. Okay, now let's continue our mission to solve this problem here. Okay, so the first and foremost things, any multiple angles or any angle that has this equation, especially factors and defactorization, like I told you in the previous video, always rearrange it in the order of the greater angles first and the descending, because that way when you do this c minus d and c minus d, you don't have to do a lot of mental calculation. You can always take the bigger angle first. For example, if you, instead of keeping sine of, like if you keep sine of 4a and sine of 6a, and if you try to apply this formula sine c plus d, then the c minus d will become 4a minus 6a, which will be negative 2a. Not that it's a problem, the equation can be applied anyhow, but why should you just introduce negative angles and try to open up room for silly mistakes? That if you arrange it in the greater angles first, it will become 6a minus 4a, and you can easily solve that. Just saves you a little bit of time and reduces your room for error. Okay, and like I said, don't touch the 5a, keep this 5a separate towards the end. Just deal with the other two equations, and then we can see how it works out for us. So the left hand side, now we are solving the real problem. The left hand side I'm going to rewrite. So I'm going to say sine of 6a plus sine of 4a, just going to put this brackets here so that it's easy to understand, plus sine of 5a, I'm going to leave it untouched. Similarly, I'm going to rearrange at the bottom. I'm going to say cos of 6a plus cos of 4a, okay, and plus cos of 5a, because I don't want to touch this also. Okay, so I've written this like this. And if you see now the first two angles, like I said, if you take 6 and 4, either you add or you subtract, it will be divisible by 2 because you want to apply this formula. So 6 plus 4 is 10, divided by 2 is 5, and 6 minus 4 over here is 2, and divided by 2 is, again the 2 cancels out and the angle becomes a. So that means you can apply this formula and you're not going to get an odd value like I mentioned in this red color over here. And if you see the pattern for the numerator, just see the pattern, right? The angles are same, 6a and 4a. Only thing is, in the numerator it has got the sine, and in the denominator it has got the cos. Other than that, when you apply this formula, the c plus d by 2 and c minus d by 2, that base is going to be the same because the angles are the same. So the two formulas that you're going to apply is sine c plus d. The first formula you're going to apply for the numerator, and for the denominator you're going to apply cos c plus cos d, for this, and then you're going to just work it out. Okay, so let's apply that. So if you see here, sine C plus sine D is equal to 2 sine, you add both the angles, divide by 2, and then you subtract both the angles and divide by 2. So let's apply the formula straight away, and I've just written this formula here. In exam you need to write this formula so that you can get the marks. That's kind of the standard rule that you have. So over here I'm going to write left hand side is equal to 2 of sine 6a plus 4a upon 2 into cos of 6a minus 4a upon 2 plus sine of 5a, the whole divided by, and since the angles are same, this portion is going to be the same, so you just have to replace with the cos function. 2 cos of 6a plus 4a upon 2, and again cos of 6a minus 4a upon 2 plus, you need to take this angle here, cos of 5a. Don't forget that angle. Okay, basically I've just applied these two formula here, the first one and the last one. Okay, now let's solve for this. Remember, you have to get the right hand side somewhere like this. It should be either a tan a, or you should approach tan a by, even if you get sine phi of 5a upon cos a, you can cos 5a, you can get towards tan a. So always keep that in mind. That's the reason I've written in the right hand side. So now let's start substituting this. So if you take my left hand side, 2 of sine, the numerator is, and this is 6 plus 4 10a, 10a upon 2 into cos of 2a upon 2, okay, plus sine of 5a, that is still untouched, divided by, at the bottom also the angles will be same here, 10a upon 2 into cos of 2a upon 2, and the last trigonometric function, which is I'm not touching it yet, is cos 5a. Let's keep going. So if you take the cancellations, let's okay, over here, so this becomes 2 of sine 5a into cos of a. Pretty much I'm just trying to divide this. 10 by 2 is 5, and this 2 and 2 gets cancelled, and then I'm going to put the brackets, and I'm going to keep this sine 5a as it is, not touch it, and at the bottom also the angle will remain the same, cos of 5a, cos of a, because the 2 gets cancelled, and I'm going to just get the cos 5a, which is still untouched so far. Okay, now if you see, there's a pattern here. The numerator and denominator have the 5a angle as common, so let's get this common angle, this one, right? If you see, this 5a and this 5a is common, this 5a and this 5a is common, so let's get the common angle, and then let's see how it functions. So if we take the common angle over here, so the sine of 5a will be the common, and then, and if within the brackets you're going to get 2 cos of a plus 1, the whole divided by, at the bottom you get cos of 5a as common, and sorry, okay, and the brackets will be again 2 cos of a plus 1, because that's how you get it. If you see here, the cos a is here. If you take cos a and you open up the brackets as common factor, this is how you get, and if you just double check it, you can see it. Now the things that within the bracket in the numerator and the denominator are going to cancel out because they are the same, and if you see what's left over in this blue color, it's like sine 5a upon cos 5a. That looks like this equation over here, and if you get this equation, you can easily get tan 5a. So this can be rewritten as is equal to tan 5a, and that's what you wanted on the right hand side, and hence proved. So this is how you solve this problem. Simple substitution. Just a reminder, rearrange the terms in the descending order, get the greater terms on the left hand side just for ease of calculation. the right hand side, whatever is the right hand side, whether you take any of these problems, right, just try to simplify it as much as you can. Sometimes it'll be just one step simplification. Like over here you have tan 5a, you just moved it one step down, sin 5a, and up on cos 5a, just to make sure that the left hand side is approaching towards that. It really helps you. And the other thing is, always check what is the angle on the right hand side. On the right hand side you wanted 5a, right, over here 5a. And if you see that angle over here, which is going to be the case in the most of the cases for factorization, defactorization, do not touch that angle for the timing. Just keep it for the last. In case you need to touch it, keep it at the last, in the last iteration. And what does that mean? Instead of applying the sine and cosine of formulas on the first two equations, on the first two functions, we just took sine of 5a and cos of 5a as a separate thing, and we swapped the places, and we applied this formula on the first and the third function, and then just we solve it, and we were trying to see, can we avoid substituting this, which helped, because when you saw this coming in common, which will be always happening in such type of problem, you'll always get whatever is the odd angle, which thinks that, hey, how am I going to solve this odd angle, how do I calculate that? Somehow the trick is, it will, after the substitution, it will happen that the odd angle comes out as a common and cancels out by itself, or it comes as a common, and you don't have to substitute further, because in the right hand side you want the angle to be 5a, which is still an odd angle, but they're not asking you to substitute further. So those are the kind of hints that you need to pick it up while solving these problems, and then just keep going and see whether you're approaching the right hand side step by step. Like right at this step, I get to know that I'm approaching in the right direction, and hence tan 5a. So since I've written it here, it's easy for me to relate that. So that's a good thing. So that's how you solve this kind of problems, where you have the right hand side as just one trigonometric function. If it's a left hand side, the principles remain the same, but I will just help explain you the minor tweaks that you need to make. Otherwise, on the left hand side, you'll exactly solve this problem the way you're solving this problem. The only thing is how you deal with the right hand side in terms of substitution, that we will see in the next video. Thank you.